Hello everyone, very good afternoon. My name is Sangram Mohanty, and today I'm going to demonstrate a video how to connect to Snowflake using Azure Data Factory and perform incremental data load into a Snowflake table. So let me share my screen and let's first proceed. All right. So this is my Snowflake table called stream.products table that is present in the clickstream database. Stream is the schema and we have a table called products. So we have some data in it called these are the set of 12 set of records. So we are going to establish a connection to the Snowflake table and load data into it from Azure SQL. Okay, so the source for this system is Azure SQL. In this Azure SQL, let me show you the data in this particular table. We have an Azure SQL table, and this is the source where I am loading the data using incremental ingestion into the Snowflake table. Okay. So let me give a brief how the incremental ingestion is happening. Now the incremental, okay. So in this product table, we can see that each product has a start date and a price end date. So price end date, if the price end date is null, that means that particular product pricing of that given product is active. If the pricing end date of a given product is set to a given value is not null, then that means that particular pricing of that given product is inactive or has expired. Okay. So here in the incremental ingestion, there will be three things that I am going to do. If any new set of records I am loading into this product table, those will be loaded into the Snowflake table that I showed into the Snowflake. If any quantity for the active table for the products that are active, if any quantity is changing, then that should also reflect in our Snowflake table. And if any a product where I am setting the price end date and creating a new entry for the same product, then then the new entry should override the old entry. So basically, this is like a data that is in the SCD type 2 model, but the data in the products table, it's in more of like a SCD type 1 model. Okay. So every time the new records, only the new, only one copy of each of the products will be present, and only the latest data will be shown in this given table. All right. Now let me come to the pipeline. Okay. Now let me tell you how we are establishing a connection. Now go to the link service. So I have already established a connection called link service. In the link established connection to Snowflake. So come to the Snowflake. Let me tell you how I'm doing it. Now come to the Snowflake, establish, create, click on new and click on data store and select Snowflake and select Snowflake V2. Not V1, V1 won't work. It won't show in your data data sets. Okay, so you need to select Snowflake V2. Now go to the LS Snowflake that I've already created and let me show you how it is created. Now account name, you have to give a name first here, your name, then come to the account name. What is the name? And the account name is organization ID and your account and your account ID. So how do you get it? You can get it from the admins section. If you go to the account section, now if I click on this manage URLs, you can see this is the portion. Okay, uh, this is just copy the organization ID and the account ID to here. Then come to the database. Yeah, database, what in which particular database your table is residing. Then warehouse, you can go to the warehouse. It is in here. Warehouse. Yeah, it's here. Admin, in which particular warehouse you need to use to load the data into the Snowflake. So that's what you may need to mention here. And where it gone? Okay. And authentication, it will be basic authentication. Then give your username. What is your username to log in into the Snowflake account? Give your password. Role, it's like what is that role associated with a given username? Is it account admin? If it is anything else, like yeah, place it accordingly. So role is important because that helps you uh, to preview the data from the or read the data from the table. So it can be account admin or database admin, okay, or security admin, whatever. Like it's all up to you. Accordingly, you will be able to see the data. Okay. Okay. This is how you establish a connection. Now come to the data sets. Now I have created this data set called. No, this is the data flow data sets. Yeah, it's the data set here. Yeah, DS Snowflake products. Okay, I chose the correct link service for that and chose the given table where I need to load the data. This is the stream is the schema and tables is the products table. Okay, you can enter it also manually. That is done. Now come to the data flow. Now data flow, to perform the incremental ingestion, we require two sources. First is your source system where you will where you are going to read the data, and the target system to compare the data with the source system. Okay, so the target is our Snowflake and the source system is our Azure SQL. Okay, so I performed also similar in similar way only. I have established a connection with the Azure SQL the way I did it for Snowflake. Okay, now selecting only 3 columns. Now coming to the Snowflake, let me show you how it is proceeding. Now we have 5 columns already. You can see the inspect, product ID, product name, department ID, unit price, and quantity. Okay. Now I don't need the in the select transformation. I only select only three the columns: the product ID, product name, and department. I don't need the other one, that is unit price and our price and the quantity. Okay. And the cast transformation I have applied on one of the columns. So in the Snowflake, one of the column when I initially read the data, it was in the decimal type. So I'm casting it into the integer type to perform a join. Okay. Now similarly in the Azure SQL source, I joined it. I performed a lookup transformation with the source system with the target, that is no, to check what are the new set of records that are present, that are all present in the Azure SQL and not present in the Snowflake. So that is why I performed a lookup. It's like a compare. It's like a left transformation. I'll more of less say. Okay, I performed a lookup transformation basis on the basis of product ID. Now, yeah, these are the all set of columns that we are getting from the from Azure SQL. And last three, yeah, I performed the select transformation. I renamed all those columns: product ID, product name, and department ID. These are the last 3 columns from the Snowflake. Okay, now now created a Windows transformation here. Now, what is the purpose of applying a Windows transformation here? Is like, say, you can just see this source system here. Consider for iPhone this particular record. Now, if the pricing of a given product is expiring, we are setting the pricing end date to something, and then we are creating a new uh, price, if a new price for a given product. Okay, so in this way we are creating some duplicate entries here. Now my purpose of creating a Windows transformation here, so that I can identify what are the duplicate entries and what is the newest entry out of it by applying applying ranking on it, and the other set of records are considered as old records where the rank is not equal to 1. Okay, that's why I created rank transformation. Now create, and then filter transformation. What is the filter transformation here? What I can do is I can preview it also if you want. Rank transformation. Okay, let me go to rank transformation and apply preview. Yeah, you can see how the rank is coming up here. Now for let's go for iPhone record. Yeah, there are a couple of iPhone records we have in the Azure SQL. Now, what is the number one, rank one? This is the newest record. Okay, the with iPhone 14. Probably 15 is the newest one. I need to refresh it. Refresh it from the source. Yeah, yeah. So the new set of records are now loaded. We have 4 set of records like iPhone product ID 15, 14, 13 and 3. Okay. So product ID 15, this is the newest set of record, and that is it set as rank 1. And product ID 14, 13 and 3 are all set to 2, 3, 4. Okay. And these are all old set of records. Now let me show you how I'm performing the ranking on the basis of partition by the product name. You can see the product name. What is the product name is iPhone. Partition by the product name. Sorting it across using pricing start date. What is the pricing start date? All are like they are in the increasing fashion. For product ID 3, you can see it's 20, then 25, then 26, then 27. All right. Okay. Good. Now come to filter transformation. Now in the filter transformation, I am going to apply filter where the pricing start date is not null, the pricing end date is not null, and rank is equal to 1. That means I am targeting these set of records, okay, where which has only, that is like we have only one copy of the same records in this given table, and whose pricing start date and pricing end date is set to some given value. This means these are already expired. These are already expired. Now, question may come up like, why don't you add this? Okay, if no, if I filter it out, then I cannot remove those from the uh, our table. Okay, so I will come like I to remove them or override them. I I have applied Azure transformation that I'm going to show you. Like, okay, products. So those set of records that I just filtered out or removed them, those filter records that I have removed them, those won't be impacted at all. They are in the incremental ingestion, their unit price, everything will remain as it is. Okay, like Tumblr. Okay, let me short. These set of records won't be impacted. Okay, from Tumblr, hockey stick, short, carom board, yeah, those won't be impacted. Okay, now coming to here, The rest of the records, I'm just showing you how the Azure transformation is happening. Now, Azure transformation, here I have set three conditions. What are the set of records that are that will go through update, and the set of records which will be inserted, and the set of records which will be deleted. Okay. Now, what are the set of records that will be updated? Where product ID is equal to the Snowflake product ID, department ID is equal to the Snowflake department ID, pricing start date and the pricing end date are not null. Okay, that means, okay, no, let me show you. Yeah, this condition is not satisfying, with either the pricing start date and the pricing end date as not null. Okay, that means I am targeting this condition. Okay, all right. Now insert, what are the set of records? Insert, the newest set of records will be inserted where the Snowflake product ID is null and ID is equal and rank is equal to 1. Now when we perform the lookup join, you can see the lookup join. I hadn't showed you the data preview. Let me show you right now. Okay, for what is happening for the newest set of records. Overly, we don't have any new set of records. All right, let me add some new set of records. Let's say insert into this. This is 16. Let's say our phone is Oppo, and this is department is 1. Pricing is, let's say Oppo is slightly cheaper, 35,000. Okay, and we have some 10 number of items. We have the pricing start date will start from 25, that is today. Okay, and it's done. Okay, me execute it. Okay, this particular record is present in Azure SQL but not present in Snowflake. Okay, so that is something that we are going to add it. Let me refetch it from the sources. All right, now let's see what is the target number 16. Okay, this is the new set of record for product ID is equal to 16. You can see the Snowflake product ID has been set to null. Okay, that means this is a new set of record. Okay, now iPhone, these are the set of records. I'll tell you, like they aren't present, but in the Azure SQL their price end date is set to some given value, so they won't be updated, rather they will be deleted. Okay, I'll tell you what is happening. Okay, so for insert we understood, for product we understood. Now coming to the delete, how the records that are getting deleted. So that iPhone, the records that I told you, okay, these are the records where after performing a rank, okay, these are their rank is not equal to 1, so those set of records I'm going to delete it. Okay, done. Now, so what does so we understood that the new set of records will be inserted into the Snowflake table. The existing records where the or the active records, active products where the pricing end date is set to null, they will be updated, and any old records where the pricing end date has been set and their duplicate present in the Azure SQL and the entries are duplicate, they will be deleted. Got it? Okay. Now quickly let me debug it out and verify the records. Okay. What we can do is, let's just say how in the Snowflake, okay, these are the quantity 11, 16 and 10. Let me update those quantities. Okay, quantity, this one. Yeah, let me update it. So that is all right. Now let's see the records. Now we will have for laptops, we will have 13 laptops. Kurta will be to 18. iPhone will be now 12. Oppo will be 12. Okay, here iPhone you can see. iPhone is 10. Oppo is not there. And laptop is 11 and Kurta is 16. Where is it? In laptop is 13 and Kurta will be 18. Is 18. So it will be reflecting here. Let me debug it out. Yeah, let's see the specs. I think it runs up very fast. Okay, that's good. Let's see. Okay, that's great. Now we see that product Oppo has been added into the table. iPhone now quantity has been set to 12. That's what we're expecting. Laptop is now set to 13. Okay, Kurta is now set to 18. Everything quantity for those active records as active products has been updated. New set of products have been also been inserted. Okay, this is how you perform the incremental ingestion. Now let's see the third. Let's test out the third condition. Okay, where we are repeating the products, where I am uh, setting the pricing of a given product to some given value. Pricing ended is set to not null, and a new pricing has been added for the same product. Let's say I added for Oppo. Okay, for Oppo, let's say mobile, that's the product ID 17. Now the price has changed to now 37. Okay, now start date will now it will start from 26th. Okay, and this is set. This is inserted, and and for this one, for the previous one, that is Oppo will previous record, and setting the pricing ended to 26th. Let's say 26. Okay, now the old record. Now this is an old record, and a new record has been inserted. Let's see. Let's show you how it is happening. Oh yeah, you can see the pricing end date has been set for the old record. That means the pricing for this given product is now over. Okay, and we have a new product whose pricing is 37,000. Okay, and the pricing starts from 26th. Okay, and this is considered active. This is the active, this is inactive. Okay, now how it is reflecting. Okay, now how it is reflecting in our SCD type 1 table. This one, what will happen is the product ID is equal to 16. This will change to 17. Okay, and Oppo, this unit price will be 37, quantity will be 10. Okay, let's see, test it out. Then debug it out. So let me introduce myself. My name is Sangram Mohanty and I'm working as a data engineer in Accenture. So I expertise in building data pipelines in Azure Database, Azure Data Factory. I create notebooks in Azure Data Factory to perform ELT transformations, and in Azure Data Factory, I perform ETL. I build data pipelines, perform ETL transformations. Okay, that's good. That's done. Let's see it. Okay, now this should set change to 17. This particular record is no more going to exist any further because this is an old record as seen in the Azure SQL. Okay, so this pricing start date and it has always a pricing end date. So that means if pricing end date I am start setting it up, this is old record. So let's see. Yes, that is working now. So see, product ID for this given Oppo has changed. Price, unit price also has changed, and quantity has now set to 10, which is expected. Okay, so this particular table is showing all the latest records for each of the products, and in and the entries or the every detail or the product in inventory details for are stored in the Azure SQL table. That is the source here. Okay, so the pricing end date, for if the pricing has to expire, then we are setting the pricing end date for a particular product. If a new if the same product is going to be launched with a new unit price or new quantity, then it is inserted by setting the pricing end date as null. Accordingly, when the we are running the pipeline, ADF pipeline, they all the latest entries of the products are reflecting in the Snowflake table. That's how you perform incremental ingestion into Snowflake. Okay, and yeah, so that's how also I have also showed you how you can perform a connection to connection to Snowflake using link service in ADF. Okay, this is a new version. Earlier, if you see, you might be using Snowflake v1, so you need to upgrade it to Snowflake v2. Okay, thank you everyone. Thanks for joining this session. Do comment out if you have any questions in this given topic, how I performed incremental ingestion to a Snowflake table. Thank you everyone.